Given the graph of the function, evaluate the function at each integer x, where x equals a in the domain. Evaluate the one-sided limit of the function at each integer x value. And then evaluate the limit of f of x at x equal to 0, x equal to 1, x equal to 2. And lastly, true or false. The limits at x equal to c of f of x exists as every c in the open interval -1, 1, and in the interval 1, 3. Part A. The only integers in the domain of the graphs are a equals -1, a equals 0, a equals 1, a equals 2, and a equals 3. Using the graph to evaluate the function at these values, f of -1, we locate x equals -1, and we would go to the function. Because of this open circle, f of -1 does not exist. The function does not exist at x equals -1. F of 0 is 0. F of 1 is 1. Notice that potentially at x equals 1 we would go to the graph, but the function is only defined if the closed circle is used. So when x equals 1, y is 1. Similarly, when x equals 2, y is 2. Again, closed circle. F of 2 equals 2. And f of 3 is 1. Part B. For the one-sided limit at each of these integers, the limit at x equals to -1 on the left-hand side. Well, there's nothing on the left-hand side of x equals -1 because the graph doesn't exist there, so we're going to skip it. But at x equals to -1 from the right-hand side, we see that the function is approaching y equals -1. The limit at x equals to 0 from the left-hand side is 0. At x approaches 0, the y value is approaching 0. The same thing with the right-hand side of 0. At x approaches 0, the y value is approaching 0. And so the limit at x equals to 0 from the right-hand side is also 0. The limit as x equals to 1 on the left-hand side is 2, and the limit at x equals to 1 on the right-hand side is 1. With the limit, make sure we follow the graphs. And so think of x equals 1 at this wall that we're going to hit. As we approach is from the left-hand side, the y value is approaching 2. And on the left-hand side, the y value is approaching 1. The limit at x equals to 2 on the left-hand side of f of x is 1, and the limit at x equals to 2 from the right-hand side is also 1. And lastly, the limit at x equals to 3 from the left-hand side is 1. And the function doesn't exist on the right-hand side. Part C. Evaluate the limit at x equals to 0 of f of x. At x equals to 0, we see that the left limit agrees with the right limit, and so the limit at x equals to 0 of f of x exists, and it is 0. The limit at x equals to 1 of f of x does not exist in this case because on the left-hand side it is going up to 2, and on the right-hand side it is going to 1. The limit at x equals to 2 of f of x does exist, and it is 1. Notice that the left-hand side and the right-hand side are approaching the same number, even though f of 2 equals 2 up there. But we're looking for the limit, not the functional value. Now, true or false? The limit of the function f at x equals to c exists for every c in the interval -1 to 1. -1 to 1, yes, it is an open interval, so it is true. Any number in the interval -1 to 1, if we pick a number inside this interval from -1 to 1, then yes, the limit exists. From 1 to 3, 1 to 3 open interval, yes. Any number we pick in this interval, the limit exists because the left limit agree with the right limit even at x equal 2.